And today I'm going to give the prior knowledge of the MongoDB. And it means, what does it mean? First of all, what is MongoDB? MongoDB is a non-relational database. Right. A MongoDB is a non-relational database. Now, and sometimes it can be called as NoSQL database also. Okay, right. Now, first of all, before proceeding to the details about the MongoDB, first you need to understand what is the purpose of database. Okay, so the purpose of database is, what is database actually? See, there are so many definitions. I'm not going with the definitions, right? So why? Because everyone aware about the database. Now, what is the purpose of a database software in the application development? So whenever you want to store data, whenever you want to preserve the data permanently in an application, we are going to use a database. So database software is used to store data, right? Now, why we need to take the help of a database software? Okay, because whenever you are developed an application for a uh, I mean, for a school or for a college or for a restaurant or any e-commerce application, right? So any restaurant like that. So when you develop the software for different domains, okay, each domain contains data actually, and it produces data when it is working on. So that you need to store all that data. You need to store that data permanently, and that data can be used by single user or multiple users. So here the data size is more. Yeah. So the data size is more, and it grows rapidly when we are using the application. The application generates so much of data, and that is stored rapidly. That is stored, that need to be stored permanently. And next, after that, it is used by maybe single user or maybe multi-user. But mostly nowadays it is multi-user. Multi-user environment. Next, we need security. That is. So simply, whenever you want to store data permanently, and whenever the data size is more, and whenever the data is used by single user or multi-user, and whenever the data requires security, and whenever I want to perform, whenever I want to manage the data, okay, means like adding of data or deletion of data. So search, find, okay, now read the data, right, edit the data. So these are all different operations, search and sort also, right, right. So in such a way, different operations, okay, querying the data. These are all the different operations required on that data. So these are all performed by the database software, okay, effectively, right. We have different types of database softwares from the olden days onwards. Like see, if you went to the olden days, like DBase, okay, like DBase plus, right. So here, next, Fox Pro. So next, Visual Fox Pro. Next, after that, SQL Server with different versions, and Oracle with different versions, MySQL, right? In such a way, different, even MS Access also. Right, different databases are there. Now, what is the common among all these databases? So all these databases are called as RDBMS databases. Simply, okay. Say I'm giving an abstract overview. Okay, I'm not going to in depth. Okay, so RDBMS, okay, relational database management systems. So what is the basic principle? See, if you want to call any database as an RDBMS, okay, there are some rules called CORD rules. Okay, among them, the first rule is any database which stores data in the form of a table, okay, is called RDBMS. And in addition to that rule, we have so many other rules. Okay, so CORD rules. A software, a RDBMS software which supports all the CORD rules or which possesses or which implements all the CORD rules is called as a perfect RDBMS. Okay. So next ORDBMS is there, object-oriented relational database management system and all. So whatever it could be, but the internal element or internal structure to store the data is table, that is. So every database in this, see every RDBMS software in this, it stores data in the form of a table. These databases may be divided into okay, two parts, or it can be divided like server databases and file databases. Okay, right? MS Access, it is a file database, whereas Oracle, SQL Server, MySQL, these are all comes under server databases, where you need to two softwares simply, client and server. Right. Whereas file database, you no need to install any software here. But whereas for server databases, you need to install client and server, and you need users and all. See, I'm giving summary. I'm not explaining the complete details, right? Now, here the most key point is table. All these databases storing data in the form of a table. So here, to manage data very effectively, okay, I mean, I want to perform whenever you are whenever you are trying to manage the data, okay, two things. Suppose, assume that there is one library, okay, a library with some 100 books. Now, whenever the library is with 100 books, I want to find my required book. It is very easy, okay, when 100 books are there. Suppose if the library is with 1,000 books, then finding for a required book is very costly process. It takes more time, right? Now, if it is the library is 10,000 books, then it takes more time. So here, simply I want to apply one search operation. I want to find a required book among the collection of books. Okay, so it takes more time. Suppose if the books are organized and divided into like category wise. So for example, BTech first year books are language wise, C language books, Java language books, C sharp books, okay, Windows operating system books, right? So Java language book in such a way, if if the if the books are divided properly based on some criteria, okay, now I want to find a book related to the MongoDB, then I will went into the databases category. In that databases category, again subcategory, okay, so RDBMSs and NoSQL databases, then I will into that category and I will select that book. It is very easy. So in the same way, whenever you want to perform the add operation and deletion operation, search operation, and read, edit, sort, and all operations in the minimum time, very effectively, without any errors, then the data need to be stored in a proper way. It should be organized. So for that purpose, okay, we are choosing table structure. So here, all these RDBMSs choose a table structure to store the data. Right. Now, to manage the tables or to interact with the RDBMS softwares, all RDBMS vendors accepted one language as as the front end language called SQL, structured query language. Right. So the structured query language is most suitable to manage the data which is in the form of tables. Okay. So now, so whenever we are learning about MongoDB, first of all, the most important, MongoDB is a NoSQL and I mean non-relational database, non-relational. Then you need to know what is relational. So, yeah, see, a RDBMS is called as Relational Database Management System. Why? Because it stores data in the form of tables. That is the most important point. So non-relational, okay, it means MongoDB not going to store data in the form of tables. Non-relational means it is not going to store data in the form of tables. Then it stores non-table format. What is that non-table format? That is the key point. Okay, that is the first one. Second one, see, MongoDB is a non-relational database which stores data in non-relational format. That is, non-relational means not table. That is right. So you need to you need to understand. Okay, you need to know RDBMS. Okay, possesses some benefits. Now it is a non-RDBMS, non-relational database, and it stores data in the form of non-relational format. Okay, what is that format? We are going to know. Now, MongoDB possesses more features and more advantages than non-relational database, than a relational database. That is important point. And it means here you need to study this one where as a relational versus non-relational. That is the key point. So the relational are like SQL Server, Oracle, and MySQL. Non-relational means MongoDB right now. Okay. So here, first of all, just a minute. Okay. Now, so here, first, what are the benefits when we are going to store data in the form of tables? See here, to create tables based on the domain data, okay, you need to know a concept called normalization. Because every topic of relational database is connected with non-relational also. Remember that. Okay. See, the topics which we are discussing right now with relational database are connected with non-relational also. So to create tables, you need to know normalization. What is normalization? See, I'm not going to teach you normalization. Don't worry. Okay. Right. So normalization is a splitting up of data. Instead of storing all the data in a single table, see, suppose if you have taken a e-commerce application, okay, it contains categories data, okay, products data, right, suppliers data, right, customers data, offers data. In such a way, different entities data is there. Now, if all the data is stored in a single table, okay, it leads to so many problems like related to the duplication and management problems and all. So you need to split the data. You need to store the data among the multiple tables so that one table, one big table need to be split up into multiple tables based on some rules. That is simple. I will tell you. in a school, I want to store student data. Now, in a book, I have stored admission data. Now, in the same book, I have stored marks data. In the same book, I have stored attendance data. Now, now the teacher requires marks data. Now, the same book is given to teacher. Now, at the same time, while the teacher looking for is working on marks, now the accountant requires fee data or admission details. So, how you can share the same book to the others? Okay, at the same time, how a single book can be used by multiple users at a time? So, it is very complex. So that you need to divide the data among the multiple books. Now, marks book, so which stores marks, and attendance book which stores about attendance, admission book which stores about attendance. So in such a way, you need to store one student data among multiple books. But the data in that books is related. That is a very important point. But the important point is data in that books is related. That is, but we know it is related. But how to map the data among the books is related. Okay, how to map them, how to relate them. That is very, very important. So marks data contains, marks book contains.
ఏందో కొజ్జా నా కొడుకు వచ్చి
Please, someone mute the. Hello. Right. So marks, admission, next attendance, yeah, yes, Dilip. Right. Attendance in such a way you can create multiple books, but that multiple books contains data that is related. See, suppose you have one student called, say for example, one student called Kiran. Okay, that Kiran's marks are in this book. Kiran's admission details are in this book. Kiran attendance is in this book. So in the same way, all the students. But how to map? How to know when I am going through the marks? How to identify that marks belongs to Kiran? Okay, how to identify that marks belongs to some other student? How to identify? So simple. The normalization is splitting up of one big table into multiple tables. That is an important point. Splitting one big table into multiple tables. Okay, why? First thing, to avoid duplication of data. Next, to perform third operations in the minimum time. Because whatever the activity you want to perform on the data, it should be done in the minimum time, means in terms of seconds or less than second. Okay. Next, to achieve accuracy, data accuracy. Right. So here in such a way, data accuracy. So here to achieve all these benefits, okay, that a single table need to be need to be splitted into multiple tables. But the data among the tables is related. Okay, it is connected. But how? For that purpose, you are going to create keys, primary key and foreign key. Right. So parent table and child table. And you may have relations, okay, between these tables, like one to one. Sometimes it is one to many, like that, or n to n also sometimes. So I will explain with one example. Don't worry. So here, by using this normalization, you are going to create tables of this RDBMS. Okay. Now let us take one example here. Right. Now here, let us see this data. Okay. So here this product data, pomegranate, one case, and this is the quantity. So this is the price and quantity. The brand name is Fresho, and the type of product is vegetable. So here, this is product data. Now, if you see the second one, this is also again banana, one case, price, and Fresho and veg. In such a way, these are all the products. These all products comes under fruits. Next, these are all vegetables, fresh vegetables, carrot, onion, potato, tomato, right? And these are herbs and seasonings, coriander leaves, chili, ginger, fresh. So these are all the data related to different products. Now I want to store this data. Okay. Now if you observe this data, this entire data is divided into different categories, right? So what are they? Now what are they? So here, see this category. Okay. So I want to store the category. So the first one is fresh fruits, second one fresh vegetables, third one herbs and seasonings, and flower buckets and bunches. These are the four categories. So I divided all the products into four categories. Next, these are supplied by two brands. One is Fresho and second one is Who Fresh. Now the products are two types of products, veg and non-veg products. Now I want to store product data. How I can store? Let us see this. I want to store product data. First, I want to store product ID. Next one is the product name, pomegranate regular. Next, after that, quantity and price. Up to here, it is okay. Now, this product belongs to which category? That is a very important point. So, it belongs to fresh fruits. So, let us take this. Fresh fruits. Next, it belongs to which brand? It belongs to Fresho. Next, after that, see this. It belongs to which type of product? It belongs to veg product. Right. Next, second product. The second is also with same. Now, in such a way, how many products you are going to create? Okay. So they are all belongs to okay, fresh fruits and a Fresho brand and type of product is veg. In such a way, just assume, just here I have to save the time, just I have entered only 2. But now assume that there are 10 products, just assume. Okay. Under the fruits category, 10 products are there, 10 fruits are there. Now, suddenly, my requirement is change the category name into organic fresh fruits. That is the important point. I want to change the fresh fruits name into organic fresh fruits. So if I have 10 products here, just assume. If I have stored 10 products here, then here I need to add organic fresh fruits. In such a way, wherever fresh fruits is there, I need to change it as organic fresh fruits. In such a way, how many replacements I need to make? How many modifications I need to make? 10. 10, because I have 10 products under fruits category, so that I need to change fresh fruits into organic fresh fruits 10 times. This is the first problem. Okay. Suppose I made 9 modifications and I forgot one modification. Okay. So I made I made 9 modifications and I forgot one modification. So that what happens, data inconsistency rises, because if I search in the database for fresh fruits, it displays 1, and if I search for organic fresh fruits, it displays 9. But actually, all the fresh fruits are organic fresh fruits. But data inconsistency is raised. Okay. So this is the main problem first. So in the same way, Fresho brand name, I want to change this Fresho into some other brand name. Okay. Then wherever Fresho is there, I need to make that modifications that many number of times. So in such a way, okay, this is the main problem. And whenever all the data is stored in the same location, right, then the problem comes. Now RDBMS solves this problem. Okay, it splits products data into multiple tables called as this category table, brand table, product type table, and product table. Now here, first of all, here see the fresh fruits and fresh vegetables, herbs and seasoning, and flower buckets and bunches. These are the 4 categories, and they are identified by a ID called 1, 2, 3, 4. That is, so category ID and category name. Okay. Now the value given for one category ID, it is not repeated. Okay, it is. So this is called primary key for the category table. Right. Next, after that, next I moved this brand name to another table called brand, where each brand value is identified by brand ID 2001 and 2002, and the brand name is Huvu Fresh and Fresho. Next, I moved product type into product type table, product type ID, and product type name. 3001 veg and 3002 non-veg. Now, instead of storing, now let us delete this. Now, just I store the product details here. Okay, not with any category and brand and product type details, just only product. Now, in my database or in my application, okay, so I want to show product detail. I want the customer is searching for fruits. So customer clicked on fresh fruits. Then it need to retrieve all the fresh fruits. Now this is product table which contains all the data. Okay, fruits data, vegetables data, all kinds of products are inside the same table. So how to identify these items belongs to fresh fruits? The pomegranate regular, we know by its name, we know it is a fruit. But how a database able to know, okay, this is fruit and this is vegetable like that? Okay. So how to know? You need to map category information with the product. Then you are able to identify. Then the software able to identify. How to map? So here, what is the relation between products and category? Under fresh fruits category, Okay, is there any chance under fresh fruits category? Okay, how many products may occur? For example, I'm not added any fruits. Okay, under fresh fruits category, it is empty. So zero products. Suppose I added only one fruit, then it is only one. Suppose I added multiple fruits. So one fresh fruits, one category, okay, carrying multiple products. Okay. So here, see this. So the relation between category and products is 1 to n. So n stands for 0, 1 or more than 1. That is. So that here this pomegranate regular belongs to category called fresh fruits, and the category ID is 1. That is mapped here. 1. And banana also belongs to 1. Right. So next. And this pomegranate, yeah, yeah, it is relational database. Right now, actually, the every concept of relational database comes under non-relation also. That is very important. Okay. When I am going to discuss, see, because here there are some points. A non-relational database is equal to relational database. A non-relational database can replace relational database. Both are equal or both are alone. Both are with their own advanced pros and cons. And which one to be used in which player, and which one to be used for in which context. That is. So first of all, yeah, first of all, here, see this. Now, next, pomegranate belongs to which brand? Okay, it belongs to Fresho brand. So that let us take the brand ID value here. Store it. Next, banana also belongs to same brand. Right. Next, pomegranate is of which type of product? Veg product. So that take the and banana also veg. Now instead of storing names, okay, here I stored the ID values. What are they? They are called primary keys. Category tables primary key is category ID. Brand tables primary key is brand ID. Product type tables primary key is product type ID. So here the product tables product ID is a product ID. Okay, product ID and product name. Now, so here, right. So now the primary key of product table is product ID. Now, to form the relation between the tables, we are going to use primary key and foreign key relationship. Okay, parent and child. So for see this, for one parent, okay, how many tail records may have? That is, under fresh fruits category, you may have 0 or 1 or more fruits, right? So here, to form the relation between these two tables, we are using primary key of one table as a foreign key in the other table. So here, see, this is foreign key, right? So blindly, if you want to form a relation between the two tables, simple thing is, I mean, at the primary level, find a common column between the two tables. See here, category ID in this category table, and here also we have category ID. So a common column between these two. But in the primary table, that column should act as a primary key, and in the child table, it is not a primary key, it is a foreign key. Here, the values are not repeated. Here, the values can be repeated. That is. See, the simple example is always simple. Remember that. When it comes to MongoDB, what happens? Okay, you need to choose. You need, suppose if anyone asks you, MongoDB can handle this entire concept, this entire context. That's the point. Okay, so that's why. So now, see, I am making it simple. Okay, rather than taking the entire e-commerce application data. Okay, see, as per my experience, okay, I worked with 58 tables in an e-commerce application. 58 tables totally. Okay, that is. So now, see this. So anyway, how we are going to solve this problem of database modification? Now I want to change the fresh fruits category name into organic fruits. I no need to touch the product table. Just enter into the category table and change this fresh fruits into organic fruits. Just I made only one modification here. Okay. And as the category information is connected with the product table through the category ID, so that I am not modifying the category ID. I am making the modification to the category name. So how many in how many locations, how many times the category name is available? Only one time. So are fresh fruits in the category table. Just enter into the category table and change the category name into fresh fruits into organic fresh fruits. So here I no need to touch the products. That is, I no need to modify this category ID because I'm not modifying the category ID. I'm modifying category name. So this is the benefit of a relational database management system. Okay. So I mean the relational database management system is more popular from the so many years. I mean decades, and it is with most comfortable one and most popular, and everyone more or less everyone comfortable with this mechanism. So now, why the non-relational database are came into the picture? Okay, that is the main point here. So why non-relational database? Okay, so referential integrity we can implement by using this primary key and foreign key. What is that referential integrity? Without entering into the parent table, it is not possible to enter into the tail table. Okay, I mean without create. See here, I have created 4 categories. Suppose can I enter a product like dals and pulses here? No, right? Because dals and pulses category is not here. Okay, so I cannot enter tur dal or chana dal or anything, right? That is. So it enforces the relational database system enforces as a referential integrity. It means, for example, in a school, okay, it is a school which is from first class to 10th class. Okay, just assume, or it is school from 1 to 7th. Can you give an admission for a student 8th class? No, because in the courses or the standards available in that school are 1 to 7 only. Okay, 8th class is not available, so you are not supposed to give admission for 8th class, right? In the same way, without entering the student data in the admission table, okay, will you enter data in the marks table? No. So first you need to enter the data in admissions book. Later you need to enter that admission students data in the marks book and attendance book. Suppose if you entered marks data for a student without entering that student data in the admission book, it becomes meaningless. That is the key point. So for every student, first data should be entered in the admission table. After that only in the marks table and attendance table. This is this is the rule, right? Now that is called referential integrity here. Enter the data first category. I mean create the category first, then enter product data. So create brand first and then enter product. Okay, create product type first and then enter product. So you can achieve this, you can enforce this rule by using this concept, primary key and foreign key concept, right? In the same way, reverse also. Without deleting the child's, parent is not allowed to delete. Okay. Suppose I want to delete all the fruits. I mean, I want to delete the fresh fruits category. First, to delete the fruits from the product table and then delete the fresh fruits category. So these are all more realistic and most suitable for real world. And we are all very much comfortable, okay, with this relational database management system. Then why we need non-relational database? Okay. Then here see data modeling, right? So today first I will introduce data modeling. Okay. In the high level languages like C++ or Java or C Sharp, or C Sharp, okay, these are all purely object oriented, purely OOPs. Purely OOPs means, okay, everything is in terms of class and objects, right? So every developer, okay, Java developer and C Sharp developer are comfortable with OOPs concept, right? I hope some of you have some knowledge about OOPs, I think. So here you are comfortable with class and objects, right? So you are comfortable with creation of objects, you are comfortable with creation of right. So now here the most important point, as you are comfortable with classes and objects, okay, you are not comfortable with SQL and you are not comfortable with I mean SQL. Okay, how? SQL is a different language actually. So SQL is with different syntax. SQL is with different syntax. So Java compiler never recognizes SQL code. Okay, C Sharp compiler never recognizes the SQL statements like insert, delete, update, select. These are all. So when you embedded the SQL statements inside the Java or C Sharp, simply the Java compiler and C Sharp compiler rejects that code and they shows it as error. That is the important point. So so here, as you are comfortable with classes and objects, is it possible to manage the backend data in terms of classes and objects instead of using SQL? That is the key point. For that purpose, a new framework is came. Okay, they are called ORM, Object Relational Mapper. Okay, in this object relational mapper, okay, take the backend table and this table is mapped with class. That is the key point. The table is mapped with class and see this, the table is mapped with class. See here, next, after that, the table contains rows. Okay, right. The table contains rows with data. Now here, the rows are mapped with objects. That is a important point. Now in this, I want to take some, I want to give some additional explanation here. Okay, the most important explanation. The table is created first. The table is designed first. That is called schema. The table contains name. Okay. Here the class also contains name. Right. Next, a table is a collection of columns and the class is a collection of properties. Right. Now every column right. Now here this column, if you select one column, if you select one column, it is mapped with one property of the class. Now here, the column is with one name and property is also with one name. Next, column is with certain data type based on the database. And here the property is also with a data type related to the language. If it is a Java language, okay, Java data type. If it is C# language, C# data type. Right. So the compatible data type. Next, if you are specifying any size here, then you need to specify here also some size depending upon the situation. Next, if you are applying any constraint here also you need to apply some constraint here, right? And it means if this column is acting as a key, okay, this property also should act as a key property. So in such a way, you need to map the structure of a table with the class structure. That is the important point. This is called schema. Next, after that, the table comes up with rows. Now here, rows is a collection of individual rows. Row 1, in such a way n number of rows. Row 2, row 3, like that. In such a way n number of rows. Now rows is mapped with objects. This is objects collection or collection of objects. Right. Now collection of objects, row 1 is equal to object 1 and row 2 is equal to object 2 and row 3 is equal to object 3. Right. In such a way, if a table contains 10 rows, then 10 objects are created. Right. If 10 rows are there, then 10 objects are created. If 100 rows are there, 100 objects are created here. So here this ORM modeling technique, okay, handles everything in terms of objects. Okay, objects are nothing but simply say, okay, they are very comfortable for developers, because developer, Java developer or C# developer or any high level language developer, okay, of a purely object oriented programming language, they feels more comfortable, okay, handling of classes and objects than tables. Okay, that is the key point. So this is the key point to develop non-relational databases. Okay, as you are using object modeling technique to handle the data. Yes.
Sir, in MongoDB, size constraint will be not there, right?
Size?
Size constraint.
Yeah, there is no limitation. Okay. See, I'm going to explain about all that. Okay, the scaling concept is a little bit different. Okay, so the vertical scaling and horizontal scaling, right? That is. So here there is no limitation. Remember that. Okay, it depends upon. I mean, size means you are asking about the size of data, right?
Yes, sir, correct.
Yeah, that is. So, but there are some problems. See that non-relational database cannot replace, okay, relational database. Both are important. Remember that. The ultimate main conclusion is, okay, NoSQL is not an alternative to the SQL. Remember that. Okay, NoSQL is not alternative to SQL. But why NoSQL is came? That is a very important point. When to use NoSQL and when to use relational. Okay, non-relational and relational. That is a key point. So whenever the programmer started using whenever the programmer started managing the data, okay, backend table by using object modeling technique or this ORM technique, then objects are came into the picture. So here, see this. Insertion a row is nothing but a database logic. Add an object. Okay. So delete a row is nothing but a delete an object. Okay. So next, suppose edit a row is nothing but a edit objects data. Okay. So delete a row is nothing but a delete an object. Select some rows. Select row or rows is nothing but a read data from one or more objects. That is, this is database logic. So this is, see, this entire class object collection of objects and the managing the objects through the methods. These are all very much comfortable for the developer instead of using tables, okay, and using SQL commands and all. So now to this ORM framework, okay. So the backend is a table actually. I mean the backend is RDBMS package. So RDBMS package acting as a backend, but by using the ORM frameworks, we are making the managing of relational database simple. So now instead of storing the data, okay, in the form of tables, okay, in the form of relational, right, non-relational database stores data in the form of objects, where the front end object modeling logic is most suitable for this one. That is a key point. Okay, so instead of, see, the back end is table and the front end logic is ORM logic. Okay, but in, so now in a NoSQL, I mean that in the NoSQL, in the MongoDB especially, okay, we are storing data in terms of objects, okay, which is, I mean, actually as per terminology of MongoDB, it is called a document, but actually it is a object, that is. So this is the main key, okay, the why the NoSQL is came. And second one is, the second one is that in NoSQL, data is stored in terms of objects. Okay, right. I'm not using the exact word related to that one, but the element which is close to your programming entity. Okay, that is objects. Now objects are most suitable in our OOPS concept. Remember that. So every OOPS developer, I mean every high-level language developer is comfortable with handling of classes and objects. That is the key point. So in NoSQL, okay, the data is stored in terms of objects. Next one. Here in the backend RDBMS, you are using multiple tables. You are using multiple tables after performing the normalization. Now here in this RDBMS, whenever you want to get all the data, for example, I want to get admission data, I want to get marks data, I want to get attendance data, to get all together as one unit. Then what to do? I need to collect data from admission table. I need to get marks data from marks table. I need to get attendance data from attendance table. By collecting all these three tables data, okay, you need to join them. So you need to know how to join one table data with another table based on some relation. So that is inner join, outer join, left join, right join. So this joins concept is a little bit complex. Okay, on the whenever the data is more, that is. So to get the required data, you need to use joins. So that in NoSQL, all the data is stored, can be stored. All the data can be stored as single element. That is, so that no need of joins here. That is the point. So no need of joins. It is more realistic also. How can you say? For example, see, if I create a class called student, just assume, if I create a class called student, okay. Now, if I see here, student, for example, student is a collection of, or student contains, okay, let us translate into normal English. Student contains student ID, student name, the course joined, date of join, fee, like this. Now, these are all single valued properties. Student ID, student name, course, date of join, and fee. Okay, the name can be divided into two parts also, first name and last name, or can be divided into three parts, first name, last name, middle name also. Now, the student address, okay, it is again multi-valued. Okay, and at the same time, a student may have multiple addresses also, right? Because so permanent address or temporary address, or the address may be changed from time to time. Okay, right. Next, the student marks, multiple values, attendance, right? The payment history, because the fee can be paid in multiple installments. Okay, first term, second term, third term, like that. Marks, first unit marks, second unit marks, third unit, fourth unit, halfly, quarterly, like that, weekly. In the same way, attendance also. It means these four are different. Okay, these five are different. These are all with single valued, and these are all multi-valued. So here, to explain about the student, this one is very easy, because marks belongs to student, attendance belongs to student, payment belongs to student. So suppose if I made payment separate, okay, it becomes meaningless. Payment, okay, whose payment it is? Okay, so is it a customer payment, or student payment, or supplier payment, or some other payment? The payment belongs to student, or student includes all this data. Yes. See this. Student includes all the below data, that is, right? So among this, address is again multi-valued. So again it is a class. Marks, again it is a class. Attendance, again it could be class. Okay, in the same way, payment also. So here, all these are, okay, implemented as one unit collection, one single collection, one single element. That is possible in object model. Okay, suppose if you want to implement the same by using relational database, then you need to create a student separate table, okay, address separate table, marks separate table, attendance separate table, and payment separate table. And these are all need to be connected through primary key and foreign key relationship. And they need to be here you need to perform join operations. You need to write join queries. So that is about relational database. Now the same five tables. See, student one, address, marks, attendance, payment. So totally five tables. Instead of using five tables, now I am using only one class. That's all. Okay. So where the student includes all these individual properties which are with single valued, and remaining all are multi-valued: address, marks, attendance, and payment. This is the concept. This is the base concept of NoSQL. That is, this is the base concept of object modeling technique. Okay. This point is clear, all of you?
Clear.
Yeah, that is. So that is the base. Now, based on this, the NoSQL, I mean non-relational databases are came into the picture. And see here, whenever you are entering into the student ID in a relational database, the student ID is here. See the student ID, for example, column name, data type. These are all called schema. So whenever you said, suppose student ID is a numeric data type, suppose if you are trying to enter non-numeric data, it shows an error because its type is numeric. It is strongly typed. Okay, loosely typed, strongly typed. The systems are okay. So here there are so many benefits from the relational database management system related to the schema point of view, related to the management point of view, and student class based on one table only created in RDBMS. Then what is the difference? See how to create address column inside the student table. It is not possible, right? Address is multi-valued. So you need to separate address from the student and you need to create a separate table address because address may have multiple rows for one student because one student at the time of joining one address is there. After 6 months they changed the address. Then one student how many addresses? Multiple addresses, right? That is. Yeah, that is. So multiple tables are required. That is the key point. In the same way, marks. One student, first unit marks, second unit marks, third unit marks, first year of, final year, pre-final, final, quarterly, half-yearly, like that. So one student with multiple marks, attendance, multiple payments. So one too many. So that's why these four need to be separated and they need to be created as separate tables and they need to be connected by using primary key and foreign key relationship. But in case of object modeling, we are going to create everything as one unit, just student. That's all. That is okay, right? So that's all for today, and this is the base for this object modeling and ORM, object relational mapping, are the base for NoSQL. That is the key point because OOPS developers are comfortable with objects, are managing the objects, right? And the class and objects are mapped with backend tables and rows. Now, in our NoSQL, the front end is object modeling and the back end is also objects. That is the key point. Yeah, that is. So tomorrow I'm going to explain about this entire flow, okay, and the basics and terms and the terminology, the basics of all MongoDB and the features of MongoDB, and we are going to see some examples and how to manage the MongoDB using MQL, okay, MongoDB query language, because RDBMS uses SQL, structured query language, okay, whereas MongoDB uses okay, MQL, okay, MongoDB query language. So we are going to see the technology related to the MongoDB and what are the different softwares related to the MongoDB and the features of MongoDB and everything we are going to see step by step. Okay, right. I will show you the installation and all.
How to store the multiple values, sir?
Yeah.
Yeah, if you want to store the multiple values means you can create another class, right?
Yeah, this class is yeah, another object. Okay. See, you are going to create it. You are asking in terms of table or in terms of objects?
Yeah, in the objects, sir, objects.
Objects. It is an array.
Okay, okay.
It is an array. Address is an array because array is a collection of values, right?
Yes, yes.
That is. So it is an array. One address is one object. Okay. If I have 5 addresses, then 5 objects. 5 objects is nothing but array.
Array. Yeah,
Okay.
array contains the 5 elements.
Yes, exactly. That is.
Sir, can we define object inside object?
Yes, exactly. Object inside the object, that is one to one. object inside the array is nothing but one to many.
Yes. So how
Yeah.
to define here, sir?
Yeah.
Non-relational database.
Yeah. Hello. Hello.
I mean, so how to define in non-relational database, sir?
Non-relational. See,
Yes,
that's why
yes.
I'm telling you now. The data is stored in the non-relational. I mean, data is stored in non-table format.
Yes, right.
That is okay, because we have different formats, but it is not table. That is okay.
Yes, I
Where,
got it. I got it. Suppose I want to create a address inside uh, 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 another object, like
yeah,
huh.
it depends on the relation. Suppose one student is with only one address, then you need to create only one object here, because address is a collection of values, right? So suppose like house number, okay, street and all. Now in such a way, I have two addresses. Suppose one old address and a new address. Then how many addresses for student? Two addresses. Okay.
Yes.
Right. Then two objects. Two address objects are required. One object, one address object carries one student, one address. One another object, another address object carries another address. So now for one student, two addresses are there. Now how to make addresses as one unit? You need to make array of objects, array of address objects.
Yes,
Okay.
I got it, sir. Suppose in an address, I will create a different, different object which is related to a pin code
If you
or a country.
if you want, you can create it. Okay, that is like a object within the object, object within the object.
Yes.
Yeah.
Yes, yes, that
Yeah.
thing's one.
That is the sometimes more advantage a feature of NoSQL. At the same time, it is little bit complex also. Okay, that is. So that's why I'm telling you, NoSQL is not alternative to the RDBMS, and RDBMS is not alternative to the NoSQL.
Yes, we have got it, sir. Yes,
Yeah.
sir. So currently, the currently is a depend upon scenario. The which scenario we using MySQL, which scenario we using MongoDB.
Yeah, yes. I'm going to give that details also completely. Okay.
Yes, yes. Okay, sir. We'll see you in the next one, sir. Okay.
Yeah, right. Thank you all of you.
Yeah, thank you.
Sir,
Thanks so much.
tomorrow timing is same, na sir?
Same timing. Yeah.
Sir,
So,
small
sir, no need to register again, na sir?
No need of that. Okay, the same link.
Okay. Thank
Same
you,
link.
Sir, how long is this session gonna go?
Hello.
Sir, what
How
is
long?
this workshop?
Hello.
So, what is the duration of this workshop?
It is around up to Friday and Saturday. Okay, 4 or 5 days.
Sir, if we have three tables, sir, category, subcategory, and products, at that time, how can we declare, sir?
Yeah, within the object within the object. Tomorrow I will tell you. Don't worry. Okay.
Yeah. Okay.
We are going with all the examples. Okay. Yeah.
Do you also teach in the weekends, Saturday, Sunday?
Hello.
Do you also take the class in the weekends, Saturday,
No.
Sunday?
Regular. See, weekend batches are different. Okay, this workshop is up to Friday. Yeah. That is.
Sir, within the
So
Friday,
after-
we're gonna complete the syllabus or how?
See, we have some syllabus. Okay, I mean we have some concepts. We are going to deliver that modeling techniques and card operations and client-side software and the front-end compass and all. I am going to show you. Okay, that is.
Okay.
It is
I
not
saw I saw the schedule until April something is like almost more than 20 days. Is that the different class?
It is not a complete class. Okay, it is just about a free workshop to cover some of the features and to give introduction about the NoSQL and object modeling and what is document and how to create database in the MongoDB and how to perform operations by using the client library and all that.
Sir, usually how much time it will take?
Yeah. Hello. Yeah. Hello. Tell me.
Sir, in the students, this address, marks, attendance, these are another classes also, right?
Yeah, another class also, but it is not possible to maintain the relation. Na? See, we need relation, right?
Okay.
See, whenever
Yes.
the marks are in another class, what happens? Actually, these marks should be a part of student. Marks belongs to student, right? See, without
Correct.
student, there is no identity for marks, right?
Marks.
That
Yes.
is the point. Yeah. And whenever you are carrying student, student should carry everything, right? If the student object is created, student object should carry all the data which is associated with student.
So
That is the main key point.
okay.
Okay, without using joins
Okay.
and
So here we are not going to add any relations here. So
yeah,
here we are
yes,
just adding the array of the collection.
yes, exactly. So I will show with an example. Don't worry.
Okay.
Okay, right.
Can we
It
have
will also-
any other NoSQL database other than MongoDB?
Yeah, we have
And
so many. Okay, we have different categories also.
And
I will show you. Okay.
What is the advantages over the SQL database? This NoSQL.
I told you now. See, you can store all the data in a single object, and next
Okay.
you can avoid the joins, right?
Okay.
You no need to write a inner join, outer join, self join, right? These are all. You can avoid.
In
Yeah.
real time, do we have any specific application is going to be used in MongoDB?
Yeah. See,
In real time?
you can use any data, no issues. It depends on the scale, the scalability, and your requirements. Okay, because I told you, relational wherever the benefits of relational database are not required, there you need to use NoSQL, and wherever the less number of entities are there, okay, that is we are going to discuss that points in the next coming session. Yeah.
Okay, thank you.
Yeah.
Sir, hello.
Yeah.
Sir, in ORM, both backend and frontend is in object, right?
No, see, whenever you are using ORM, the backend is RDBMS, the front end is ORM framework convert.
Juniper Berry Lane Northwest toward Wild Lantana Lane. Then turn left onto
ORM
Wild
framework
Lantana Lane.
generates the data access layer and the classes which are mapped to the backend tables. Okay, suppose if you are using Spring Boot, okay, ORM, or if you are using a EF core, Entity Framework core in .NET, okay, backend is maybe SQL Server, maybe Oracle, or maybe MySQL. But the front end model, the front end is a collection of objects, okay, classes. So the ORM framework generates classes and a collection of objects according to the backend tables. That is, still conversion is required. You are feeling convenient while you are working with the front end classes and objects, but the backend is still RDBMS. Okay.
So, sir, what is relation of ORM with MongoDB?
Yeah. See,
what is relation of ORM with MongoDB then?
See, now I told you now ORM is generating classes and objects, right? Now in the MongoDB, what is the basic element? It is object. What is the basic element of storage? Object. Okay, it is not table, right? So here, what is the basic element of manipulation of data in the ORM? It is object, right? One row is nothing but one object. Clear?
Yeah.
The collection of objects is nothing but table. Yeah.
Sir, there is one doubt. Like through ORM tool, we are already like storing data into the database. Like class we mapped into the database table. Then only for like we don't want to use join, so that's why we are go for like NoSQL. Other than what is the advantage for using NoSQL? Like
Yeah, that's what. See, I'm telling you. See, tomorrow I will explain with all the examples step by step. Okay. That's why I'm telling you. It is a. You need to go with the complete details of your requirements. Okay. I will tell you. So wherever the data is need to be stored as a single element. Okay. And where there are no requirements. Okay. Of relational database means relational database benefits. Right, normalization. Okay, there are, right. So you need to check all the things. Okay, certain parameters are there. You are going with that. You need to check that parameters. So I'm not saying NoSQL is an alternative to the RDBMS. Remember that. Okay.
Yeah.
Yeah.
Sir, what is the duration to complete this course, sir? Usually, how long it will take?
It is not a complete course. Okay, it is
No.
just. It is.
I mean, if you want to learn completely, what is the duration?
It depends upon the content. Okay, if you want to manage the entire MongoDB, okay, that is a different story. If you want to use the MongoDB as a backend, then it is different. Suppose if you are learning MERN, okay, in that MongoDB is the backend, right? If you are learning Mean, okay, Angular, then MongoDB is the backend, right? So
Sir,
yeah.
For Java
where
developer.
I get notes, sir?
So from tomorrow notes, I will share the notes in the Google
Okay,
Drive.
okay, sir. Okay, sir. Thank you.
Yes, sir. Please
this is the
finish
link.
As a Java developer, what is the required for the Java developer? Okay, the backend is the MongoDB. How many days or how much the time duration to complete the required concept for Java developer?
To use that, to consume database, to consume MongoDB as a part of your project, it is a matter of mostly 10 days is enough.
Okay.
Because simple thing, I will tell you.
Yeah.
You write it may be Java, or it may be .NET or any other content. Okay. What type of operations you are expecting? See, it is nothing.
Operations.
CRUD operations and the creation of object model according to your requirement in the backend, and later managing that object model through the front end queries. Okay. Here the queries means not SQL queries. It is about Mongo JavaScript based queries. Okay. JavaScript is connected with this one. Okay. MongoDB query language, MQL, JSON. Okay. We are working with JSON format. Remember that.
Yes, sir, JSON format, but you said that Java is it prerequisite for this JavaScript is required to use MongoDB as a backend?
Having of some knowledge like JSON, what is JSON format, and what is the object format, that is enough, not more than that. Okay.
Sir, in JSON format, data is in the form of key value pair. In the same way, it is storing in like MongoDB.
Yeah, here, yes, exactly. Okay. So there are two JSON formats: text-based JSON format and binary JSON format is there. Okay. It is low level and that is the top level. Okay.
So, sir, are you going to show
May I know like
MongoDB
what is binary JSON format? Like JSON format, I know I have not worked with
it is a
binary
low
JSON.
level. It is a low level format. Okay. It is which is storing level.
Like as the name says itself, like binary JSON format means it is related to 0 or 1 or like something else.
It is with multiple types of data. Okay. Data types are more. That is. Okay. Whenever you are handling domain data related to the real world, okay, it means strings, numbers, these are all very common. Whenever you want to handle non-conventional data, okay, then normal JSON is not possible. That is the point.
Okay.
Yeah. Right. Okay. Thank you all
Are
of
you
you.
going to show MongoDB Compass also, sir?
MongoDB, we are going to use
Compass.
it. Yeah, I will show you the installation and all. Okay.
Okay. So, if you want to search for particular query, so we can search on MongoDB Compass, right? So, what could be the right way to search to get into a JSON format? Hello.
You are asking about export and imports or anything? What you are expecting?
For example, if I want to search the query in MongoDB Compass in JSON format, I can directly post the query on a UI page of MongoDB.
See, I'm not unable to understand what you are expecting. See, tomorrow I will show you all the examples one by one. Okay, right? See, I'm going to show you all the CRUD operations and different query operations and all. I'm going to show you. Okay. At that time you can ask. No issues. Okay.
Yeah.
Thank you.
Yeah. Hello, sir.
Thank you. Thank you all of you.
Hello, sir. Hello, sir.
Yeah.
Sir, whatever you are going to teach in this 1 week, is it like sufficient for Java developer?
Yeah, to use a database, that is enough. Okay. You need to learn about just the connectivity. Rest of the part is okay for you. Yeah.
I have one question.
Sir, one question. I mean, earlier you said that if the front end is Angular, back end is MongoDB,
Yes.
That is one scenario. At the same time, so mern mean okay. I'm not a Java developer.
Node Express. Okay.
Okay.
The front end is React and the back end is Node Express. Express library with the help of JavaScript and database libraries ODM, it is going to connect with the backend database.
Yeah.
Sir, I have one question. So what is the difference between like one term is schema and one term is the metadata? So any difference between two?
See, metadata is nothing but it is information. Okay. It is
information of table.
It is information. Schema tells about the structure.
Structure of table.
It
Schema.
is a structure.
Okay.
Schema is a structure. Okay. Suppose student ID. What is the student ID? It is integer. Okay. Suppose, for example, numeric. What is name? It is string. So it tells about the size. What is the size of name? What is the size of student ID? What are the different constraints applied on student ID and name and I mean the rules and regulations, the course, the date format which is allowed. Okay. So the type. These are all related to the schema.
Schema. Okay.
Schema. That is, whereas metadata means it is a non-technical information. Okay. Non-technical. It is not schema. Okay.
Example like?
Example means, see, for example, what is student ID?
Okay.
Sir, what is student? What is student? It is a entity. Okay. Or what is student ID? It is a property and its information. Okay. It explains about the student ID.
Explains about but schema is the
exact structure. Student ID is integer. Okay. Our student ID is numeric. Name is string. And the maximum size allowed is some 40 characters. The minimum size is 30 characters, like that. Okay. So it is about the schema.
Schema.
Okay. Yeah. Size, which tells about the data type, size. Okay. The constraints which are applied on that column, all are comes under schema. That is.
Okay. But in
like we can say primitive information, sir. We can call it as schema. Primitive information of the table, or we can call it as schema.
Not primitive. So it is a primitive means it comes under in the different contexts. Schema means exactly the information which tells about data types, controls, constraints, sizes, and all. This is called schema. That is.
But metadata will tell about the exact data known.
The explanation about that one. Okay, it is a non-technical information.
Non-technical.
Okay. Non-technical. Student ID means student ID. Okay, it is a brief it is a brief about the student ID. That is explanation.
Okay.
It is explanation. Okay.
And where
it is not specific to any language. Remember that. Metadata means it's not specific to any language. Whereas schema it is related to some specific structure, specific suppose SQL. Okay, you are creating the table by using SQL. Then the schema is connected with SQL. That is the key point.
Okay, and where the metadata used in database?
See, the data dictionary, right? See, when you want to know about something, okay, suppose how many tables are there, then how many tables are there, how many stored procedures are there, when the stored procedure is created, who created the stored procedure. This is all about see, I'm not asking about the structure of stored procedure. I'm not asking about the student, right? I'm not asking about the table. Okay, so when the table is created, who created the table, okay, right? What is the size of the table? This is all metadata. Clear?
Okay.
You got the point? That is.
Got it.
Yeah.
And one more question, sir. This stored procedure, why we create stored procedure in database? Use of stored procedure.
See, there are two things. There is an architecture called 2.5 architecture. It means so to access, whenever you embed the SQL logic inside the data, inside the programming code, the database logic, whenever you want to change, okay, you need to open the source code and you need to modify it and all.
Right.
So, and the most important point is if the source code is opened, okay, if the source code is disclosed, suppose Java source code or .NET source code, then the embedded SQL statements are also visible. Okay,
right.
That is. So if I want to change the SQL code, I need to ask the C# developer or Java developer open the source code and modify the SQL commands.
Correct.
That is one aspect. So that what happens, whenever the SQL statements are embedded inside the code, I am able to know, okay, about the column names. I am able to know about the table names and all, because the SQL statement shows everything. Insert into table name, or select star from so and so, or select the table, these column names from table, like that. That is all. So that it reveals about the table names and column names and all. That is second one. So to avoid all these problems, okay, the queries, the SQL statements are moved from database logic to backend. That is, so the stored procedure. So stored procedure is nothing but collection of SQL statements identified by a name, right? Now now the stored procedure is called by the front end programming language by using its name. That's all. Whatever the input parameters need to be passed are passed as arguments, and whatever the stored procedure returns, that is received by the front end programming language.
Okay, it is a kind of a function, correct?
Yeah, yes.
It
Then
is a kind
the
of function.
second one, security. Stored procedure as a database RDBMS. Database is a collection of multiple users. I mean, you can create multiple users. Okay, you can provide privilege on a stored procedure. You can remove privilege on a stored procedure for a user. Because when the Java application or .NET application are connecting with the backend database, how it connects? Through a username. That is. Now for that user, if the privilege is removed on that stored procedure, even though you connected, you are unable to execute that stored procedure. That is. So the complete control is on database side. That is.
Okay.
That is the point.
And
Okay.
stored procedure is taking the data from multiple tables. It is fetching, means
that depends upon depends upon the select statements you have written inside the stored procedure. Okay. Suppose, see, the select statement is taking now you have written a join query inside the selector, inside the stored procedure. What does it mean? That stored procedure is working on multiple tables. Okay.
Right.
Suppose if it is only single select command, it means the stored procedure is working on single table. That's all.
And stored procedure can be executed like when the event is occurred, like a trigger kind of thing.
That is trigger.
Oh, that is trigger. So
That is
inside trigger, stored proc is called.
Yes, exactly. Yeah.
Okay. Means whenever any condition like click or something, we want to do something, then we need to write a trigger and stored procedure.
Yes. So if something is updated, then consequently this one also need to be updated. Okay. Whenever a record is inserted in the first table, I want to update in the second table also. Okay. Like just assume that. Okay. So whenever the first one is updated, second one is also automatically updated. It is a connected. It is a triggered. Okay. The backend one functionality is initiated through this triggered. That is.
Okay.
Yeah. Right.
Okay. Got it. Okay. Thanks. Thank you.
Yeah.
Sir.
Yeah.
So can we consider metadata as data about data?
Yes, exactly. That is. See, a table is there. When the table is created, who created the table? What is the size of the table? What are the different permissions on that table? These are all called as metadata. That is.
Yes, sir.
Yeah, that is. Okay. Thank you. Thank you, all of you. See you tomorrow.
Thank you, sir.